Ladies and gentlemen, welcome to the Conspiracy Farm, where we don't start the conspiracies, we just add the water. And now, your host of the most state-of-the-art, most informed podcast on the interweb, I present to you Pat Miletich and Jeffrey Wilson. Ladies and gentlemen, are you ready for war?
We are recording, ladies and gentlemen. We are live and direct. Another episode of the Conspiracy Farm. Jeffrey Wilson rolling shotgun right here on Zoom with my co-host, Hall of Famer, world-renowned eater of worlds, slayer of dragons, Patrick J. Miletich. What's up, champ?
A lot is up, man. I tell you what, we have a lot of stuff we could be discussing, but we're going back to the vaccine debate because our good friend George Pardos has been working diligently doing some testing and coming up with some conclusions and potential conclusions and leanings on vaccine safety. And I tell you what, a lot of people do this stuff besides Del Bigtree and a few other, that are really focused that we've had on our show. A lot of people will, do the hottest thing of the week or hit once on a subject and let it go. But we got to keep coming back to this because the science is not settled, right, guys?
No, absolutely not. And that was actually really cool in the conversation with Del and George. Both very educated on both sides, quite frankly. And George, this is like, as we promised, his follow-up to the follow-up because,
we're going to keep following up.
Yeah, and he had some questions as well. And the coolest thing about it is he actually went into the lab and started doing experiments and more.
He's a doer, not a talker.
Well, yeah, and some of the very interesting information from the last follow-up talking about, I don't want to misquote you, sir, but it was kind of genetically specific how some of these abnormalities were developing with these vaccine applications. And it was really cool because George made the best point of, we can have all the stats in the world. We need the science, man, the definitive science to determine the pathology between the link between the application of these vaccines and then the maladies that wind up coming up. And George has just been awesome with his time and helping us out, getting some more answers to these questions. George, how you doing, buddy?
I'm working a lot, and I actually, I want to thank Pat about this because had we not had the conversation on Del Bigtree about your gluten allergy, we would have never came across the line that we started testing in the last few weeks.
That's interesting. I'm glad that happened by chance.
And I'll tell you the reason why this came to be, and just a little background, because I want to give credit to where credit is due, because it's not there's a gentleman. By his last name is Chu. His name is Sung Young Chu, and he did an article on the HLA. And one of the things that he had isolated was your gluten allergy. And when we started looking at some of the libraries and saying, hey, listen, we need to test some things because we're just there's too many patterns that are emerging, and I think that this is where we wanted to start testing. And when we pulled that up, your gluten allergy was on chromosome 6 on the human leukocyte system.
Okay.
And so we said, wait a second, if the antigen is on that system and the allergy is on that system, and some of your antigens are carried on the chromosome 6, maybe there is a hereditary pattern that is emerging in not just vaccines, but antibodies and antigens. And so we started, basically, that took us down a road that for the last 3 weeks, we've been injecting mice and we have a theory. And now it's not something we're going to be able to develop overnight, not in a month, not in 2 months, but I think by next.
What about the conclusions of stuff first?
Well, the conclusion is here's what we've come to find out. When we injected mice, we usually injected them with a duophosphate, which blocks the macrophages. In these mice, we did not. We just injected the antigen, and then these mice are bred specifically for our testing and for antibody testing and antigen testing one of the things that we found out, and this is where I think that we are going to expand the study on, is there's a peptide. And when you already are, your DNA already has the antigen present, when you inject with, let's say with a vaccine, and is that the peptide does not let you, the receptor will not let the vaccine attach to the antibodies.
Okay.
And that is, and
Which results in?
well, here's the thing. When we tested for afterwards, we tested to see in the brain barrier, there is some residual carryover in the brain and the neural system.
Okay.
What is not is in the brainstem. So basically, you would have problems with, let's say, walking or physical skills, but not cognitive skills.
Okay.
We have, we
Physical autism and mental autism, the difference, or
right.
traits.
Or a Guillain-Barré, is that something that fits that?
Yeah, it would fit something like that, and it would look like that, because here's what we have seen is that if you already have the antigen present, and it's not in all of them, and let me say this, it's not in all the mice we tested, but there's a percentage of them. So I think that, when you test mice, you have to test with and without, a control group. When we tested with the control group, we have gotten some really, I don't know what you want to call them, some weird effects. And what we have seen is the antibodies are not keeping a geometric shape that we were expecting. So what that means by is that the receptors, for some reason, when you already have an antibody present, resist the vaccine. Because what we've done is we tested an MMR vaccine. We then tested a DPT vaccine. And what we've noticed is on some of the mice, the receptors are not letting the vaccine adhere to them. If I'm explaining the Barney style.
They're not able to connect with it because it already exists in the first place. And
the receptors is already
projecting a false version of itself. What?
Right. And then so when you take a look at the microglobulin, then there are markers that we're seeing in the proteins that, now mind you, we've only tested it on a limited amount of mice. We've only run the first test, and we have to run,
This is monumental stuff, though. We're getting reporting back on the first test of this kind.
Yeah, and so we didn't expect that to happen. We did not expect that to happen in it. And so what we looked up was this. What we looked up was, like I said, the gentleman's name, and you guys can take a look. His last name is Chu. He talked about the HLA system, and it was the genetics, immunology, clinical testing, and clinical implications. And he marked he basically marked where the antigen specifics were on the HLA-A, HLA-B, HLA-C, and HLA-DRB1. And he marked it to where the alleles are. And there is some interesting work. And so what we did is I said, okay, listen, he looked for basically, where the markers were in the immune responses. And for those that are listening, chromosome 6 is where it is tied into your immune system. And when you're looking at certain things, one of the properties is how are you resistant to a certain disease based on your HLA and based on your chromosome 6. So in your chromosome 6, because you have a gluten intolerance, that was probably passed on through your mom, and she probably has a certain marker. So what the short version of this is, we're seeing somewhere there's a pattern that is emerging where that whatever the antigens are, they're not absorbing the vaccine, or they're not upset. And we've also tested some other compounds that are, that you would, and when those antibodies are present, they're not accepting them. Now that's not in all of the mice, and in some of the mice, they accepted them, they moved forward. It was, but in some of them, and the reason that we did is we gave them the equivalent of 3 doses. We gave them multiple doses. Now the one dose, we had a control group for 1 dose, control group for 2 doses, a control group for 3 doses. And we said and in each one, you had some adverse conditions, which translates to that there are some people out there that we're thinking, and this is where we want to get to a certain test, is that we can do a genetic testing to people on the HLA and chromosome 6 to see how they would respond to certain antibodies. And I think that's long term where we could get to.
Can't hear you, brother.
Chromosome 6 is the weak point.
Yes. And that is where, if you look up chromosome 6 and the HLA, it's called the human leukocyte antigen. And you have to test. One of the problems is the HLA genes are very polymorphic. So
Polymorphic.
Excuse me?
Polymorphic.
Yeah. And they have a lot of different alleles. But if we are going to go down the road and say, hey, listen, we need to make not just vaccines better, but other drugs as well. And the process is called pharmacogenomics, is that you create a drug to that person's DNA. And what my DNA might...
Yeah, I was reading up on that. You told me to read up on that. It's very interesting stuff.
And so what I think is happening is that within the next year, I think we could figure out a way where we can create a marker to say, hey, listen, in this subset, with an antigen or an antibody already present, people are going to have an adverse reaction. I think that may be a path that we can prove, and we have a lab out of California that we've engaged in that is it's a independent lab. We can get
right.
Independent testing. We have one that we use in Missouri and one in Ohio, and we're going to run. Basically, what we're planning on doing is running 3 different tests across 3 different platforms, and then compare the numbers and do computation biology and say, hey, this is it. And then what we are going to do is actually ask people for DNA and that have had adverse reactions if they're willing to cooperate with us.
So here's the political implications of all this, though, and I just see a much bigger picture where your studies could actually end up reversing these psycho laws in California that say the unvaccinated cannot be in any public location, can't go to school, things like that. I mean, because they're deliberately putting people at risk, and it's almost goes without saying that these politicians, look, they've either got to be compromised or paid off, because there are masses of people that are out in.
Here's what I think happened is I don't think that they know enough. Here's what let me say this. What I think is happening is they don't know that this is possible in the human, let's say in the human body, that they don't think that this is possible. And because of that, they have to, what is the greater group, not the lesser group. And here's what we think we can create, or at least expand on. If we take a titer test and expand 4 fields with it and
right.
say, listen, this person already has this vaccine present, or this antibody present, they have no, basically they're not at risk. here's the test. If they pass, boom. Because here's one of the other things. And work it backwards from what you just said. How would you know if a person did have a test?
Well, I think, here's the thing. Here's where we get into the legal part of it. I mean, I understand you want everybody, and everybody would want to know if their kid's allergic to a vaccination potentially that could, do a lot of damage. So, I mean, that makes sense. But where do the rights of the people? That's where it's, this actually gives the people that are fighting for individual rights and religious choice are going to obviously side with you. They need your evidence.
Right. And what we're saying is that here's had we not started looking at this and the HLA, one of the things we would have not thought of to do is, look at the membrane, the membrane, the cytoplasm and all that. And what we think is happening. This is, and again, we just begin this. We're going to start testing more. We've got a test that we're going to do in August that we're going to expand this, and what I don't think people have contemplated in history is that we, as a whatever you want to call it, as a society, whatever, that we would be resistant to certain diseases because of cellular memory. I don't think that ever came up in conversation with people.
That's cutting edge, flat out, is what it is.
And so if we can create a test, and I don't know that, like I said, we just started this, but I think we've ran this by immunologists and certain doctors, because there's a lady that was on the Del Bigtree show that actually used the same, I'm not going to say the
same verbiage.
Yeah, same verbiage. And for you guys, for anybody that's listening,
people are listening to you is what the point is, right? Yeah,
is that her name is Teresa Deischer, and she's a DNA expert. And here's where this is what concerns me, and down the road, I don't want to give blanket vaccines to everybody. And this is where what I want, because here's one of the concerns. There are people out there, and we've gone through VAERS, the vaccine database, and we've looked at there's a pattern. There is a pattern there, and I think that there's legitimate concerns, because it's not just one. And I think that what we have to say to people, and especially because what I don't want is I don't want to have a revolt. I really don't. I don't want to have a revolt where people are saying, "Hey, listen."
But you're a Marine. You'll be okay.
Well, I'll be fine. I started training and all that. I mean, the whole thing is that what I want to happen is saying, "Hey, look, this is the process. If you have a child and they have these
antibodies are present.
Antibodies are present. They don't need vaccines. And if they don't have them present, this is where you're going to have issues at. And these are the ones. And if you are at least,
what about the HPV that's been killing kids?
I'm going to say this. I don't have enough research material to give a scientific answer.
That's the scary one, man. They're all scary. Some of the potential damage to, specific, gene pools, whatever. But the HPV, people are dropping from coronaries, right?
Right. The HPV, and we've done a little bit of that. We've actually looked at some of the research, and we've looked at how it works. It's a very HPV is its own animal, so to speak. The way it works in a human body is much different than a DPT vaccine, an MMR vaccine, any of the other one. It's a completely different animal. So with that, part of it too is that because Gardasil had 3 failures before the FDA moved it or approved it, however you want to say it, they're holding a lot of information closer to the chest. What I think is happening is in certain people, especially females, is because women process certain drugs different. I think it is affecting their neuroskeletal system differently, and that's what's causing them to have coronary. They've had 14 heart attacks on it, and that's not, and the 14 heart attacks, 7 of them were the lower anterior descending artery, which is not something that you have in
young kids.
It's something,
Right.
You have a smoker that's 70 years old.
Right.
I mean,
right, yeah.
And again, going back to, from a scientific position, we don't have enough research to test that one. And we eventually will get there, but that's not our first concern. Our first concern is and we're not singling out any of the antigens or vaccines or any of them. What we're singling out is saying what is causing the adverse reaction in the human systems,
Right.
that is coming, that we can test on. That we can say, because if you say to me, hey, look, let's say you take arginine, right? You're a proponent of that. You take arginine. I can measure the effects of arginine by the human growth, the amount of human growth hormone you have. That's a, before and after. I get a baseline. If you take an arginine,
It's supposed to up the amount.
Right. I can test that. I can test for the pathology. And so what we have done is with all the testing, and we've used some other compounds and antibodies. It's not just, we're looking at the brainstem, we're looking at the nervous system, we're looking at those cells, and we're looking at how they're, how they are reacting if they've already have an antibody present. And I think that's and again, we have some really, the people that I'm working with, we have some really good, I don't know what you want to call them, some very smart people, and they're saying, hey, listen, this is where you need to, this is where we need to look. Because when we presented it to, we have I don't know what we're going to call it, but we have kind of a board that, we look at, and when we talked to the board, we said, hey, listen, this is what, and the 2 doctors on there said, yeah, that is a very, and one of them is a DNA specialist, and he said, yeah, that's the way you need to go. And he says, they agree with that. So we haven't had, even in peer review, when we've talked to some people, no one has said, oh, you're stupid and crazy, you don't know what you're doing.
During conversations, do you guys talk about potential conclusions and what impact that could have on the industry of vaccine?
Yeah, we have those conversations.
I mean, that's got to be an interesting conversation for you guys, because you're the ones that are impacting it potentially.
Well, let's say that we come up with a test, and this test says, hey, listen, what we need to do is we need to separate the, let's say the MMR vaccine into single doses, and instead of having that combined, have it individually. And that way, to some people it would and then also the delivery system might be a little bit different as well. Maybe what we do is what everybody has done, and this is where, and I think that with the Human Genome Project, where information kind of, there's so much of it, you have to parse it. Okay.
Right.
We're looking at people like yourself. Your kids aren't, you didn't get vaccinated. Okay. Your kids haven't had adverse reactions to anything. They, you said, and
they don't get sick. Like they sneeze once in a while.
Yeah, but let me ask you this: do your kids get? Do they eat peanuts?
Yeah.
Okay. I mean, are they gluten allergic?
Potentially, they could potentially be.
And so, like I said, the other problem that we're having there's so much information by the end of the day that we have to go through and parse and make sure that it's not, when we're doing the research, we're trying to not have a cognitive bias. We're not saying, listen, the results are what they are. They're scientific. If we see the cells are acting adversely, what is causing that? And I said, we've seen them when the antibody is present, and we do, inject them with more of them, the cells are not geometric, and that's what that's not what we were looking for. We weren't looking for that. That's not something that we said.
So basically, the cells are being destroyed.
No, the receptors are. It's the equivalent of
The gates aren't open.
The gates aren't open. It's like checking a kick. If you're trying to kick somebody and the guy checks you, the kick is still going to go through. It just doesn't connect. And it's the same thing which is happening
with what's injected.
With what's injected. And like I said, we have some we've had some decent tests. And going back to this, I think that one of the things that we've kind of because I've gone through and looked at some of the Dell's work and other people's, that are proponents of saying, hey, listen, the science isn't settled and we're having adverse reactions. So what we can say is we haven't found anybody that's been blinded by any vaccine yet. We haven't found anybody that's been blinded by a vaccine, which tells me that the vaccines are going through the neuro system, not always going into the brainstem. And that's important.
That's very important.
Yeah, because that tells me that it's neuroskeletal instead of. And here's one of the other issues that there's a girl that had a vaccine that had that had Guillain-Barré syndrome. Okay, if she was sitting down, you would not know that she was sick. She got up and was walking, and she had, literally, she was walking. It looked like she was developmental, had developmental issues. So what we haven't found is there are some mechanisms you can introduce to say, hey, listen, because it's not hitting the brainstem, but it's hitting the neuroskeleton, there are some mechanisms that there's some prophylaxis out there that you can use to protect people.
Very interesting, man. Jeff?
I mean,
wow.
it's.
Yeah, I'm just. Go ahead.
Talk, Jeff.
Go ahead, Jeff.
You've been silent.
No, I've been listening, man. It's all so very fascinating, man. It's just this kind of very, very diligent science has to happen, like down to
It's incredible.
No,
This is work, and we're covering it step by step with him.
And I think these pharmaceutical. I mean, I think they probably have done this, and they know this information clearly.
I don't think they did. I don't think they did. And
maybe not the pharmaceutical companies. Well, I mean,
here's the comical thing about it is George refuses to give credit that someone else might have been intelligent as he is.
But like we talked about in the last update, the LDA is the least deaths allowed. I mean, they've done the studies. They've know the certain aspects.
Right.
And I'm not saying nothing about but what I think, here's what I'm not saying that the pharmaceutical industry hasn't done this, but it's just like the guys in the University of Buffalo that were testing for the MS, the MS gene. What they found out is if you block it, instead of helping the body's immune system, you use a blocker, and to stop the myelin damage, you have positive results. Well, interferon has been around for 30 years. Nobody thought to introduce a blocker. They would just said they wanted a helper. So could the pharmaceutical companies have done this? Maybe. But it's the same thing. The pharmaceutical companies have made penicillin, and they know that there are people going to be allergic to it. And because it works for the 90 percentile, they don't say, hey, what did we create? We create a test for those people that are allergic to penicillin. We create a test for those people that are allergic to peanuts.
You brought up that phrase polymorphisms, or I mean, you can't really give like a one shot for everybody because everybody's kind of deficient and different.
Right.
Their biological makeup's just different.
And here's the thing, what we've thought of is, and everybody has said, listen, we're just going to inject a little bit part of your, we're going to inject a little bit of the disease into your system to make your immune system be able to fight it better. So when if it does hit, your immune system has basically institutional memory. Well, that's great, but it might not always, if you've already have it present, you might have an adverse reaction. It's just like the same thing. Your car needs oil to run. You put too much oil in there, what happens?
Bust a gasket.
Yeah. So I think maybe it's the same thing that we're doing now, and we're not. What I don't think the pharmaceutical companies that have done, or they didn't realize this, or maybe they did and they just didn't care, is that they didn't think that, as with many people, that you would have people that are resistant. Yeah,
I mean, it makes sense. It makes perfect sense now that we've talked about it several times. So, so you're going to do some more rounds of tests here in August, you're saying?
Yeah, we need to parse the data that we've already came up with. We need to look at look at some cells underneath a microscope, and we need to do some of the samples that we've already collected, and basically see where the hole is. Because what we want to do in the next year, and we want to test, we want to get some people that have had adverse reactions, and we talked about this the other day.
Yeah, we'll finish with this because this is really important.
What we want to do is basically we want to run more tests, and we want to see what levels does that you have with HLAs, with where is the issue, and exactly where's the peptide is it the peptide that's blocking it? Is it, where exactly is that coming from? And at what level is your antigen present that is going to block any of the vaccines, any of the antibodies from coming in? And
are you wanting a test group of kids that have been injured?
Yeah, that's what we're looking to see. And if I don't know that parents would agree to that, or I think
a lot of parents would. Jeff, don't you think?
I think so, absolutely. Like you said, it's going to become, one of these constitutional issues of people, like, you can't be just doing medical procedures on my kid without my permission.
But I'm saying the kids that have been injured by vaccines, the parents agreeing to a test with George and his group to do tests on them and find out what went wrong, how it went wrong.
That's the kind of science we need. We need those who've been adversely affected.
Yeah.
Well, and here's one of our guesses, and one of and this is the last part, and we can close in the next few minutes. But there's a gene called FOXP2. Okay.
FOXP2.
All right, and that is the gene that is it makes humans' ability to talk, and basically have conversations, have language.
We have 1 minute and 30 seconds until our Zoom shuts down, my friend.
If we can mark, we have that genetic marker that we can code. I think it's possible that we can code whatever other genetic marker is causing people to have an adverse reaction. And I think we can get there. Maybe not today, but
no, absolutely not. But through the diligent science, man, I think those answers will be found, man. And it's so cool that you're back on to do these follow-ups, because you're obviously going deep into it. And this is, like I said, exactly what we need, man. I
think it's incredible, and for everybody out there, make sure you check out theconspiracyfarm.com. Go and support all of our sponsors: Chemical Free Body, My Patriot Supply. Pick up some Conspiracy Farm garb, right, Jeff?
Absolutely.
Done Right TV, brought to you by Done Right TV, Butcher Box, the best organic meats out there, and T4 Concealed Carry Clothing Company, right?
Absolutely.
Did I get those in, buddy?
You did, my friend. You did. You still got a minute left. But yeah, thank you, George. And obviously, when you come back, keep giving these updates, man, because this isn't the stuff we're getting from the news. You and Del Bigtree have more in common than you do different. And that's why I thought that debate, quote unquote, debate was so awesome.
And this is the thing. We're going to keep doing the research. So when people
It's
online
incredible information.
Absolutely.
do the research, no, I am doing it.
Boots on the ground, ladies and gentlemen. George Pardos, man, friend of the show. Can't thank him enough. Peace and so much love, guys. Until next time. Holla.
Bye-bye.